Good morning, grade 11. Thanks for your participation, Hussein. Okay, and I hope that you will enjoy, inshallah, with my session, chemistry. Okay, first we are going to go to the next lesson, which is called reaction rate law. Reaction rate law. Okay, so the reaction rate law is an experimentally determined mathematical relationship that relates the speed of a reaction to the concentration of the reactant. Okay, so first, reaction rate law. Okay, depends on what, or make a relationship between what? It's a mathematical relation. Okay, between the speed of a reaction to the concentration of the reactant. It's okay. So after that, the vocab that we studied before, reactant, and we said before that what's meant by reactant. Reactant, it means the substance that enter the chemical reaction, okay? And after that, this reactant will be changed, okay, to produce new product after the ending of this reaction. So it's called reactant. As if we said that 2 mg plus O2 produce 2 MgO by heat. So 2 Mg plus O2 are called reactant because they before the arrow is the first. Second, they are the reactant that will join and make chemical reaction together to produce new product. It's okay, so it's called reactant. After that, this is the vocab that we studied, but the vocab that we are going to study in this session, inshallah, number one, rate law, rate law. Number two, specific rate constant, specific rate constant. Number three, reaction order, reaction order. Number three, method of initial rate, method of initial rate. It's okay? So, after that, the essential questions that you are going to study, inshallah, in this lesson, number one, what is the relationship between reaction rate and concentration? What is the relationship between reaction rate and concentration? Number two, how are reaction orders determined using the method of initial rate? How are reaction orders determined using the method of initial rate? Okay, so writing reaction rate law. First, a rate law expresses the relationship. A rate law expresses the relationship between what and what? Between the rate of a chemical reaction and the concentration of reactant. Okay, so writing reaction rate laws. A rate law, a rate law expresses the relationship between the rate of a chemical reaction, the rate of a chemical reaction, and the concentration of reactants. And what? And concentration of the reactants. Okay, as this one-step reaction rate law. Rate law is equals to K times A. What's meant by K? K is a constant. K is a constant, so which will be known. A represents the concentration of a reactant. Represents concentration of a reactant. So the rate of a one-step reaction, the rate of a one-step reaction is the product of the concentration of the reactant and a constant. Okay, so the rate of a one-step reaction is the product of the concentration of the reactant and constant. Okay, so the rule will be rate equals K times A. K constant, as we said, and A represents concentration of reactant. Okay, any problem till now? Okay. After that, writing, writing, okay, reaction rate loss. How can we write this reaction rate? The simple K is the specific rate. Simple rate is the specific rate. Okay, a numerical value that relates the reaction rate and the concentration of reactants at a given temperature. Okay, so the simple K is the specific rate constant. It's called what? Specific specific rate constant. Specific rate constant. Okay, a numerical value, a numerical value that relates what? A numerical value that relates the reaction rate and the concentration of reactants at a given temperature. Okay, the specific the specific rate constant is a unique for every reaction. Specific rate constant is unique, K constant for every reaction and doesn't change by changing the reaction. Okay, it's related to K, which is called specific rate constant. Understand me? Okay. After that, this is the reaction of what? Reaction order for reactant. The reaction order for a reactant defines how the rate is affected by the concentration of that reactant. As the rate of reaction equals K H2O2. H2O2. It's okay. So the reaction is first order. Reaction is first order. So the rate changes in the same proportion. The concentration of H2O2 changes as this. This is initial reaction rate, initial reaction rate, okay, measured by mole divided by liter times second, okay, so is the rate of reaction, and this is the H2O2, its concentration, mole per liter, mole per liter, okay, so H2O2, okay, opposite initial reaction rate as this, okay, so the reaction order for reactant defines how the rate is affected by the concentration of that reactant, as this concentration will be decreased as what? As rate equal K H2O2. Okay, the reaction is the first order. Reaction is the first order. So rate changes in the same proportion. The concentration of H2O2 changes. Okay, so after that, this is to determine reaction order. The method of initial rates determines reaction order by comparing the initial rates of a reaction carried out with varying reactant concentration. As initial rate measures how fast the reaction proceeds, how fast the reaction proceeds at the moment when reactants are mixed. Okay, as experimental initial rate as for A small a capital plus B small b capital to produce product. Okay, so trial number one, okay, initial of A and initial of B, 1, 1, 0.2, 0.2, 0.2, 0.2. It's okay. Initial rate will be changed as 2 times 10 power negative 3, then 4 times 10 power negative 3, then 16 times 4 times 10 by negative 3. So initial rate measures how fast the reaction proceeds at the moment when reactants are mixed together. Okay, so it's called determining reaction order. Determining what? Determining reaction order. Okay, so after that, Writing reaction rate law. How can we write this reaction rate law? General rate law is, as we said, rate equal K, which is called constant, K, times A, M, times B, N. Okay, what about this? A and B represent the concentration of reactants A and B, as we said. So A and B represent the concentration of reactants A and B. The exponent M and N are reaction order. M and N are reaction order. It's okay. So the rate of a reaction, is equal to the product. Rate of the reaction is equal to the product of K and the concentration of reactants K and the concentration of reactants, each raised to power, okay, each raised to a power order that is determined experimentally, okay, the general rate law. As 2NO, it's a gas, plus 2H2 gas equal N2 gas plus 2H2 gas. So the rate K NO2 H2, okay, NO, and its order will be 2. Why? Because it consists of two molecules. These two molecules will be as this, as a power. So K is the rate of chemical reaction. NO and H2 are product. So NO power 2, okay, times H2 times H2. It's okay. If H2 is doubled, if H2 is doubled, the rate doubles. The rate doubles. If NO is doubled, the rate will be what? Will be quadruples. Okay? Will be what? Will be quadruples. Why? Because 2 power 2 equal 4. Well, it's doubled because as NO at the beginning, 2 molecules. So if the reaction will be doubled, so 2 power 2 will be 4. First order H2, second order NO. Third order overall. Overall. It's okay. So after that, doubling A doubles reaction rate. So A is the first order. Also doubling B, okay, quadruples the reaction rate. Okay, quadruples the reaction rate. So B is the second order as rate equal what? Equal K. A first order times B second order. Okay. So this is the session, sample session that we studied. Okay, and I think it's a simple lesson, this session. Okay, now we're going to make review with the question that we studied and parts. Okay, essential questions that we studied. Number one, what is the relationship between reaction rate and concentration? Number two, how are reaction orders determined using the method of initial rate? The vocab that we studied this lesson, number one, rate law. Number two, specific rate constant. It's okay, reaction order and method of initial rate. Okay, thanks, Hussein, for your listening and your participation for this session. Okay, and now inshallah we are going to go to Magro Hill site. Okay, Magro Hill site to ask some question about this lesson. Okay. Okay. Question number one. Question number one. Okay. The rate law for the reaction between nitrogen monoxide NO2 and hydrogen is rate 2 K equal NO2 power 2 times H2. What happened to the rate if the concentration of nitrogen double? Nitrogen double. It will be what? It will be what, Hussein, if doubled? Okay. Can you use your annotate and write? Okay. So it's called what? Can you write the answer, Hussein? It's okay. I think that we are going to choose what? Things we are going to choose the rate will be quadruples. Why? Because NO2 equals 2. So it will be 2 power 2 equal 4 as we said. Okay, question number 2. The exponent in a rate law expression define what? Define what? Which describes how the rate is affected by concentration of the reactant. Describes how the rate is affected by the concentration of reactant. Instantaneous rate, concentration, specific rate constant. Okay, what? Okay, specific rate constant. Question number 3. What is the overall reaction? What is the overall reaction order for the following rate law expression? K rate K, A, B2, C3. So what is the overall reaction in order to following? Okay, 4. Okay, 4. After that, how are the rate law? How are the rate law and order for a complex reaction determined? How are the rate law? By calculating, by experimentation, by trial and error, by estimation. By what? By calculation. Okay. Last question. As reactants are consumed and fewer particles are available to collide most chemical reaction, it will be what? Most chemical reaction. As reactants are consumed, okay, and fewer particles are available to collide, most chemical reaction will be speed up, slow down, stop, continue at the same rate. Will be what? Will be slow down. Okay. So can we are going to grade our test. It's okay. Oh my God. So the first question rate of quadruples, as we said. Number 2 will be reaction order. Reaction order. Number 3, it will be 6. Okay, because in the first order A, second order B, third order C, adding 1 plus 2 plus 3, total will be what? Total is 6. According 1 plus 2 plus 3, 3 plus 2 equal 5. 5 plus 1 equals 6. So it will be 6. By experimentation, not calculation, it will be slowed down. It's okay. This is the test, okay, about the our session. Okay, so I think we finished our session. Okay,
السلام عليكم.
Salam warahmatullahi wabarakatuh.
يا أهلا.
After finishing our session, okay.
حبيت بس جيت أسلم عليك أستاذ.
تسلم يا غالي، تسلم يا غالي، ما نحرمش منك يا غالي. تسلم، كل سنة وأنت طيب. كل سنة وأنت طيب. So we finish this lesson. Okay, thanks guys for your participation, and I will send it inshallah to WhatsApp group and to our SPS site. Okay, مدرستي في بيتي. Okay, good luck, guys, and I hope that you will enjoy, inshallah, with your time. It's okay. Thanks for your participation and goodbye. See you soon, inshallah.